Next up is lesson 11.2, which is formula mass and molar mass. In this lesson, we're going to learn how to solve for formula mass and molar mass, as well as how to use those as conversion factors for dimensional analysis. Formula mass is the sum of the average atomic masses of all of the atoms in the chemical formula, and the units are AMU. You might recall this unit because it's the same unit as the average atomic mass, which makes sense because this is the sum of the average atomic masses in a chemical formula. So for example, on the periodic table, the average atomic mass of carbon is 12.01. So if we were to calculate a formula mass, we would be using that average atomic mass of carbon in our calculation. So let's take a look at just exactly how formula mass is calculated. So we're going to start by multiplying the number of atoms of a particular element in the formula by the atomic mass from the periodic table in AMU. And then we're going to add the mass of each element together to get our total formula mass for the compound. So for example, and this is the example from your study guide, carbon dioxide is made up of carbon and oxygen. And there's one carbon in that compound, and there are two oxygens. Looking at the periodic table, the formula mass of carbon is 12.01 AMU. Whenever you take formula masses from the periodic table, always record them to 2 decimal places. So 1 carbon formula mass is 12.01 AMU. 1 times 12.01 is 12.01. Then we do the same thing for oxygen. 2 oxygens in our formula, CO2, and the formula mass for oxygen is 16.00 AMU. So the formula mass for our oxygens is 32.00. Then we add those together, and the total formula mass for CO2 comes out to 44.01 AMU. And we can do this for any element or formula by simply counting up the number of atoms in the formula, multiplying that by their formula mass, and then adding them up to get the final total for our compound. So now you should try the rest of those problems in your study guide. So formula mass is awesome, but the units AMU are not super helpful. So molar mass is actually the unit that we're going to be using a lot more this year. Molar mass is the mass, and there's a typo here, it's the mass in grams of 1 mole of a substance. Good news is, I know I just taught you a calculation, but molar mass is actually calculated in the exact same way as the formula mass. The only difference is that our units are grams per mole. And the mole, as we learned in the previous lesson, the mole is the amount of particles, 6.02 times 10 to the 23rd particles in 1 mole. Again, the good news here, again, is that our calculation looks exactly the same. The only difference that you're going to notice in this calculation is that unit. So calculating the molar mass for CO2, we've got 1 carbon. The molar mass is 12.01 grams per mole. 2 oxygens, and the molar mass of each of those oxygen is 16.00. So that's 32. Then we add them together, and we get our, another typo here, molar mass of 44.01 grams per mole. So once you have recorded this example in your study guide, I'd like you to try the rest of the examples in this problem. All right, so now that we have an idea of what a mole is and how to calculate molar mass, we're going to be using molar mass and Avogadro's number to do some dimensional analysis. So there's a place to copy this down in your study guide. So I'd like you to just take a moment and do that. And once you have that copied down, make sure you just pay careful attention to the direction of these arrows. So if you're starting with mass, so if I gave you a measurement of 2 grams of something and we wanted to convert that into moles, to get from mass to moles, you need to multiply by the reciprocal of the molar mass. And one way to remember that that's what you're going to need to use here is that mass has a unit of grams. Moles obviously is a unit of moles. And molar mass we know is grams per mole. So remember, with dimensional analysis, we're looking at the units. And you'll notice that molar mass has the units of grams and moles in it. So that's why we're able to use it to convert between mass and moles, grams and moles. So if you're going from moles to grams, you're multiplying by that molar mass. And if you're going from grams into moles, you're multiplying by the reciprocal. Then moles to particles, we're using Avogadro's number, and we're either multiplying by Avogadro's number or multiply by the reciprocal of Avogadro's number. And remember, we learned in 11.1 that Avogadro's number, 6.02 times 10 to the 23rd. And the units for that are particles per mole. So again, we're seeing that we have a conversion factor that has both of the units that we need in it, which is always a really important part when you've got conversion factors. Moles to particles, and then this is our conversion factor. We're either multiplying by Avogadro's number or we are multiplying by the reciprocal of Avogadro's number. Something important to remember about particles is that particles can be anything. It's just a placeholder word. So they could be atoms, they could be cars, they could be molecules, anything that you're counting the number of that you have in a mole, that's what your particles are. So this roadmap is useful to remember what conversion factor you need to get from mass to moles or moles to particles, and then also what you're doing with that conversion factor. You're either multiplying by the reciprocal or you're multiplying by it. This kind of simplifies the layout. I personally usually look at the units when I'm doing my dimensional analysis versus looking at the roadmap, but I always like to offer a bunch of different options so that people can learn it in different ways. On the next slide, I'm going to do some example problems with these conversions, going back and forth between all the different possibilities. There's 4 different possibilities. As you can see, there's 4 arrows. And I'm going to show you the way that I do it, which is by looking at the units. But you can always refer back to this roadmap as you're working through these problems to figure out how to do them. All right, so now we're going to take a look at some dimensional analysis problems using these conversion factors. Avogadro's number, 6.02 times 10 to the 23rd particles per mole, and then molar mass, which we just learned how to calculate, pulling the numbers off of the periodic table. So no matter what kind of problem you're doing, even if you don't know what kind of problem you're doing yet, you always want to start by writing your given information. So in this first problem, I have 3.5 moles of carbon. And we're solving for molecules of carbon. Notice that as part of my unit, it's moles of carbon, and I included that in my unit, in my setup. So starting with 3.5 moles of carbon, we're trying to convert to molecules of carbon. So I can tell that this is a dimensional analysis problem because we're switching our units. So anytime you're doing dimensional analysis, we're going to set up a conversion factor, which remember is a ratio. So draw your fraction line. Now, the unit that you start with, moles of carbon, we need to cancel that out. So I'm going to take that unit and I'm going to bring it to the bottom of my fraction because that's what's going to cancel out that unit. So I'm just going to write moles of carbon on the bottom. And then the unit I'm solving for is molecules of carbon. So I'm putting molecules on top. So now I have to ask myself, do I have a conversion factor to get from molecules to mole? And it might feel right away like you don't. But remember, Avogadro's number, 6.02 times 10 to the 23rd particles per mole. And that word particles, oops, too many humps in my M. That word particles can refer to whatever you're counting, which in this case is molecules. So I know how many molecules there are in a mole. There are 6.02 times 10 to the 23rd. So 6.02 times 10 to the 23rd molecules per 1 mole. And before we solve this, we're just going to make sure that we've successfully converted our unit. If you look at our conversion factor, what we want is on top, molecules of carbon. What we were given, what we've got, moles of carbon, is on the bottom. So that's a good conversion factor. And we can just double check by making sure the unit we started with cancels out and the only unit we're left with, molecules of carbon, is the one we're solving for. So now we can go ahead and solve this. We've got 3.5 moles times 6.02 times 10 to the 23rd divided by 1. Remember that first number, if it helps you kind of see that it's in the numerator, you can always put it over 1. So I'm going to multiply this out using my calculator. 3.5 moles of carbon times 6.02 times 10 to the 23rd divided by 1 in my final answer. We're going to get 2.1 times 10 to the 23rd molecules of carbon. Don't forget to check your sig figs. We started this problem with our measurement 3.5 moles, which had 2 sig figs, and our answer here, I've rounded it to 2 sig figs, so 2.1 times 10 to the 23rd molecules of carbon is our final answer. So that's one type of dimensional analysis problem you're going to do with these conversion factors. Next problem here shows another type. So this one, we're starting with 5.43 times 10 to the 31st molecules of CO2. So again, I'm going to start by writing my given information, 5.43 times 10 to the 31st molecules of CO2. And we are solving for moles of CO2. So I want to cancel out my molecules. And I want to solve for moles CO2. We're going to use the same conversion factor here because if you look at our fraction, it's the reciprocal. Molecules are on the bottom, moles are on top, but it's still the same units here. We still have molecules and moles, which is the same units as Avogadro's number. So Avogadro's number will be our conversion factor that we put into this. So Avogadro's number 6.02 times 10 to the 23rd particles per mole. And make sure you're putting that number in the right spot. It goes next to the particles. So on this problem, my particles are on the bottom, so it's going to go on the bottom. 6.02 times 10 to the 23rd molecules per 1 mole. Our molecules of CO2 are going to cancel out. We're left with just moles of CO2, which is what we're solving for. So I'm going to type this into my calculator, and I'm going to get my final answer. And this comes out to 9.0 times 10 to the 7th moles of CO2. Again, sig figs, 5.4 has 2 sig figs, so 9.0 is what we round this to get our 2 sig figs for our final answer here. Example number 3, this time we're starting, it's worded a little bit differently, but I've kept the purple color here to show us our given information. We're starting with 3.25, 3.25, fix that 3. Moles of carbon. And we're going to convert that into grams of carbon. So what we are starting with is moles of carbon, and what we want is grams of carbon. What you want goes on top, what you've got goes on the bottom. So now we take a look at this conversion factor we set up, and this time we've got grams per mole. So we cannot use Avogadro's number here because grams aren't a type of particle. Particles are things you can count. You can't count grams. You measure grams. So the unit grams per mole is the unit for molar mass, remember. So all we need to solve this is we need to know the molar mass for carbon, which if you look at the periodic table, the element carbon, its molar mass is 12.01 grams per 1 mole. So 3.25 moles of carbon times 12.01 grams of carbon per 1 mole, that cancels out our moles. It's going to give us our grams of carbon, which when we type that into our calculator, that's going to give us 39.0. Whoa. Sorry, my pen just went a little crazy there. Let's retry that. So 39.0 grams of carbon. And we started with 3 sig figs. Our answer is rounded to 3 sig figs. So that would be our final answer. Last type of problem that we have, this time we're starting with grams and we're solving for moles. So again, same setup. I'm going to start by writing my given information, 6.05 grams of helium. Notice I always put the unit and the substance whenever I'm doing this. 6.05 grams of helium, got a little stray mark there. We're converting that into moles. So conversion factor, we're starting with grams of helium, and we want to convert that to moles of helium. Looking at our setup here, we've got grams and moles, but this time grams is on the bottom. So the only thing that's going to change is when we put in our molar mass of helium, which from the periodic table we can see is 4.00 grams per 1 mole. That 4.00 goes on the bottom of our conversion factor because this time we're multiplying by the reciprocal of our molar mass. So that's what I meant in the roadmap where I said multiply by the reciprocal. We can see that the molar mass grams is on the bottom, whereas up here, to get from moles to grams, we multiplied by molar mass. So that's why grams was on top. So we have this set up. Let's just check to make sure our units cancel out. We're starting grams of helium. We're canceling out grams of helium. All that's left is moles of helium, which is what we're solving for. So we type this into our calculator, 6.05 times 1 divided by 4. This comes out to 1.51 moles of helium. So this is an example of each of the 4 types of dimensional analysis we're going to do with Avogadro's number and with molar mass. So the first problem, we started with moles. We were solving for molecules, and we multiplied by Avogadro's number. Second problem, we started with molecules. We were solving for moles, so we multiplied by the reciprocal of Avogadro's number. Third problem, we were starting with moles. We were solving for grams, so we multiplied by the molar mass. And the fourth problem, we started with grams, solving for moles, so we multiplied by the reciprocal of the molar mass. Remember, in each and every one of these, the easiest way to figure out what operation you need to do and what conversion factor you have to use is to follow the units. Look at the unit you were starting with, put it on the bottom. The unit you want goes on top, and then we solve. And that's going to be the case in every single one of these dimensional analysis problems. If you're having trouble reading any of my handwriting on this slide, the typed out answers are on the next slide, so you can take a look at those. But after you followed through those, I'd like you to try the rest of the problems in 11.2. On this slide, you can see that I just color-coded those units for you to help you see where they always go so that they cancel out, but it shows the exact same work. Unit you started with on the bottom, unit you're solving for goes on top, fill in that conversion factor. And then always make sure you check your sig figs in your final answer. When you are doing out the rest of the problems at 11.2, make sure you're showing all of your work. That includes all of your numbers and your units. If you don't know where to start by writing your given information and then see if you can set up that conversion factor. Always take it one step at a time. So that's it for 11.2. Try your best with the rest of those problems. We'll go over them in class and have fun, everybody.